So in this lesson, we're going to learn a couple of things. We're going to learn what is area, we're going to learn how to find the area of a rectangle, how to find the area of a trapezium, and how to find the area of a triangle. So first off, area is the number of square units that cover a two-dimensional figure or shape. So for example, the square here shown in blue covers an area of 4 square units. The rectangle here shown in green covers an area of 8 square units. And finally, the triangle shown here in brown covers an area of 2 square units. So the formula for the area of a square is sides squared. So if you know the measurement of one of the sides, then you simply square that measurement and you end up with the area of a square. That is because all of the sides of a square are equal. So for example, if we have a side with a measurement of 2, then we simply multiply 2 times 2 and we end up with 4 square units. Now if we have a bigger square with a side that measures 40 square units, we're going to multiply that times 4. So 4 times 4 is going to give us 16 square units. The formula to find the area of a rectangle is length times width. So we simply find our dimensions. In this example, we have a length of 4 and a width of 3. So we simply multiply 3 times 4 and we end up with 12. So the formula for finding out the area of a parallelogram is base times height. So what that means is we calculate the bottom section, the base, and we multiply it times the height. The formula is identical to that of a rectangle, length times width. So if you ask yourself, why is the formula for the area of a parallelogram the same as the formula for the area of a rectangle? Well, if you see the figure shown below and you cut out where the red dotted line is, separate that triangle, and then move it over to the right, we can see that a parallelogram is basically a rectangle. It's just shifted a bit. So the formulas are the same. Area of a triangle equals 1/2 times the base times the height. So to find the area of a triangle, we simply multiply the base times the height and then divide by 2. So just like any other area problem, we find our dimensions and then we work it out. So there are 2 ways to make a right triangle into a rectangle. The first way is to use all of the height and half of the base. So if we separate that bottom right corner with this dashed line in red and we rotate it, we can see that we're going to form a rectangle. The second way to make a right triangle into a rectangle is using half of the height and all of the base of the triangle. So we cut along the red dotted line and we start to rotate and we can see we formed again another rectangle. So if we divide the scalene triangle into 2 straight triangles, we can easily find an equivalent rectangle as shown. So we start rotating and we see that we have another rectangle. That is why the formula stays the same. Base times height divided by 2. The formula for the area of a trapezium equals 1/2 times a plus b times our height. So if you cut off the 2 triangles and move them as we're about to show you, the trapezoid becomes a rectangle. For example, the left side we start rotating and it becomes a rectangle. So that rectangle has the same height as the trapezoid and its base equals the average of the 2 bases. So here we can rotate our right corner and we see that again we formed a rectangle. The area equals the average width times our altitude or our height. So to wrap this up, do these 2 triangles have the same area? Why or why not? Try to work it out and figure it out. So let's find out right here by drawing again our rectangle. We're going to rotate this. So after some rearranging, we can see that in both of the triangles, we have the same area, an area of 8 square units. And in each case, the area of the triangle is equal to 1/2 the area of the rectangle. Writing. In your own words, explain the relationship between the area of a rectangle and the area of the triangles created within the rectangle. Readiness. Determine solutions for problems involving the area of rectangles, parallelograms, trapezoids, and triangles.